Good morning, everyone! We are now going to discuss the third type of mathematical modeling, which is the flow or mixing problems. A typical mixing problem deals with the amount of salt in a mixing tank. Salt and water enter a tank at a certain rate and mix with what is already in the tank, and the mixture leaves at a certain rate. To determine the rate at which the salt leaves in the tank, this is the formulas. So in order to calculate the volume of the brine at which the salt leaves the tank, we can use the V is equals to V sub 0 plus ET minus FT. V stands for the volume, V sub 0 is the initial volume, ET is the brine that enters the tank, while the FT is the brine that leaves the tank. So next is the concentration of salt in the tank at any time t is Q over V sub 0 plus ET minus FT. Last is the rate at which the salt leaves the tank is F times Q over V sub 0 plus ET minus FT, or d theta over dt is equals to BE minus F times Q over VO plus ET minus
A
F.
600-gallon brine tank is to be cleared by piping in pure water at 1 gallon per minute and allowing the well-stirred solution to flow out at the rate of 2 gallon per minute. If the tank initially contains 1,500 pounds of salt, A. How much salt is left in the tank after 1 hour? B. After 9 hours and 59 minutes.
So in order to get the volume, we're going to use this equation. So V is equals to, our initial volume is 600 plus the brine that enters the tank has its value of 1 and the final is 2. So V is equals to 600 minus T. To calculate how much salt is left in the tank, we're going to calculate the amount of salt left in the tank after 1 hour. So dQ over dt is equals to BE minus F times Q over V sub 0 minus ET minus FT. So equals 0 minus 2 times Q over our V sub 0 is 600 plus 1 minus 2t equals to negative 2. Q is over to 600 minus t. So negative 2Q over 600 minus t. So now we're going to integrate dq over q is equals to integral of dt over 600 minus t. Is equals to 2 ln times 600 minus t squared plus ln c. So ln q, we can put this as ln c times 600 minus t squared. So q is equals to c 600 minus t squared as we divide both sides by ln. So we can use this equation to get the value of c. So when t is equals to 0 and our q is 1,500 pounds, which is our initial, so we can compute it by substituting 1,500 equals c and 600 minus 0 squared. We can get the value of c as 1 over 240. So now that we get the value of c, we can substitute this to this equation. So Q is equals to 1 over 240 times 600 minus T squared. So now we're going to calculate the amount of salt left in the tank after 1 hour. So our T will be 1 hour, which is equals to 60 minutes. So now we're going to substitute this to this equation. Q is equals to 1 over 240 times 600 minus 60 squared. So we can get the value of Q as 1,215 pounds. So the amount of salt left in the tank after 1 hour is 1,215 pounds. We're going to calculate the amount of salt left in the tank after 9 hours and 59 minutes. So our T will be 9 hours and 59 minutes, which is equals to 599 minutes. To substitute this time to this equation, so Q is equals to 1 over 240 times 600 minus 599 squared, which is equals to 1 over 240 or 0.0042 pounds. So the amount of salt left in the tank after 9 hours and 59 minutes is 0.0042 pounds. So now we are done discussing the third type of mathematical modeling, which is the flow or mixing problem. So now we are done discussing all the types of it. Remember the Newton's law of cooling, the growth and decay, and lastly the flow, mixing, or problems. So thank you!